I guess just to set the stage for folks who maybe have heard the term long-running agents, but have maybe not tried to build one or haven't seen one in action. A lot of the agent demos that you see tend to be stateless. You ask, the model will answer, and then the conversation sort of ends. And even if the demo lasts like 10 or 15 minutes, it's still living inside a single context window. And that's going to get filled and then it'll get discarded. A long-running agent is really the opposite. It's an agent that maintains its state across sessions, and it operates over a longer period of time. So we're talking hours, days, maybe even weeks at some point. And your unit of work isn't really a prompt. It's a workflow. So the agent itself owns a multi-step process end to end. And before I show you a demo, I want to say that there are kind of three things that have to be true for all of this to work. The first is that the agent has to truly be able to sleep. It's a lot like a person. It needs to truly be able to sleep. So some of the ideas we might have used before, things like active polling, doesn't need that. You don't want that. You don't want to have a block thread that is just sitting there burning compute. And it also has to be able to be dormant until some sort of external event can wake it up. That might be a webhook, might be a schedule, a human approval, some sort of human interaction, or a tool callback. The next thing that has to be true is that every step kind of has to have a checkpoint. That state that we talked about, a lot of things being stateless. State in this case has to be durably persisted on every transition. So, even if your container running all of this crashes, you still want the server to be able to redeploy, and a human can then take whatever number of days to, complete an action. For example, if we were going through, employee onboarding, or we were going through a loan processing setup, however many days it might take for someone to actually complete an action, the agent needs to be able to still pick up exactly where it left off, with no hallucinated memory or intermediate steps that ever happened. And the third thing that's important is that the agent can't grade its own work, right? We've seen lots of people use agents where you'll use the same agent to write your code and then the same agent to review your code, right? And I feel like you need a little bit more nuance to your approach there. Research from a number of labs, including Anthropic, has been pretty conclusive in terms of when an agent evaluates its own output, it consistently overrates it. It's almost overconfident about the quality of the outcome. And so you don't want quality to be mediocre. And the state of the art in this kind of setup is really having a 3-agent setup. You want some sort of planner, you want a generator, and you want a separate evaluator that can test your live result. All right, so here's a visual of what long-running agents actually look like. And if we put those 3 ideas together, so durable states, event-driven dormancy, and separated evaluation, you really stop having a chatbot. You have something that's able to complete multi-day workflows, multi-week workflows. There's so much in our lives where we're working with businesses or we're working with other entities, and it just takes a long time because of the nature of the business to get everything done, to get everything signed, to get everything analyzed, to get things checked off. And long-running agents are perfect for helping us compact those workflows and have agents actually work in the background for us, supporting them. Kind of want to show you the 3 walls that agents almost often hit. First of all, we have context degrading, right? So even if you have a long context window, that can fill up pretty quickly, and it can lead to quality dropping. Every single session can end up starting from 0, and you don't want that. If you've got a long-running, agent, you ideally want to be able to have it continue and still have context about the problem that you're working on. The next one is that we haven't had so many primitives for persistent state. And without external structure, you can have agents that drift, they can break things, or they can just give up because they don't have all of that state and they don't understand the full context of the problem. And then we go back to that self-verification that I was talking about. If a long-running agent can't tell if it's actually done, that's a problem. And if they praise their own work, even when it's bad, that's also something that we don't want. And so The three big breakthroughs that have really enabled us to go far here are agent harnesses. Agent harness engineering, agent harnesses have really gotten better in the last year. And so you're able to have a harness with agents that can plan, build, evaluate. You don't just have a monolithic loop. You're able to have persistent memory patterns. So any of those living plans throughout the whole session can be treated as markdown. You can have change logs as your lab notes. You can have, people have talked about long running loops, things like even the Ralph loop. You can have Ralph loops running in here even, where you're able to just make sure that you're ensuring that the task gets completed, and then manage infrastructure. On the Gemini Enterprise Agent platform, just as one example, we're able to have sessions and memory bank for long-term memory. And that's really the productized version of this stuff in action.